Hey everyone, today we are going to be doing problem solving with fractions and decimals, also known as word problems. We're going to be looking at some information about addition, subtraction, multiplication, and division because we have used all four operations at one time or another. When we talked about operations with decimals, we did do all four, so adding, subtracting, multiplying, and dividing. This week we've been talking about fractions, and last week we talked about fractions. We've only been doing multiplication and division, so that kind of narrows down your choices. So I've got some look-fors here, so things that you're going to look out for or pay attention to while you're reading the word problems that are going to help you decide which operation you're going to use. We're going to go through how do I know when to add, subtract, multiply, or divide. And then we'll walk through some practice problems before you guys try some on your own. So how do you know when to add? You're going to add when you're asked to find the total. So there are many, many words and phrases and things like that that mean to find the total. When you're looking for the full amount, when you're looking for something altogether, when you're trying to combine things. So there's many different ways to say find the total. For subtraction, you're going to be finding the difference. What's the difference between these two things? How many more does someone have or something have? How much is left over? How much change are you supposed to get? Things like that are going to be subtraction. Those are going to be specific to decimals. Now, division and multiplication can be both decimals and fractions. Division has the most because there's the most different ways to use division. So how do I know if I'm going to divide? If it asks for one, each, or per, those are going to be your unit rates. So you're going to divide to figure out how much for one of something. How much of something is inside something else. So you have a space and you're trying to fill that space. How much of the object can fit in that space? How many times more? So if I have a big quantity and I want to know how many times bigger that thing is than something else, I'm going to do big divided by small. If I have a total amount divided equally, the definition of division is to share something equally or to share in equal groups. So if I'm sharing something, I'm going to divide. And then if you're given the area and one of the sides, or one of the dimensions, you can find the other dimension using division. How do you know when to multiply? If they use the word of means multiplication. So if I have 2/3 of something, or if I ate 3/4 of a bag of chips, or something like that, that's going to mean multiplication. And then area and volume are also multiplication. So we're going to go through several examples here, and we're going to do fractions and decimals. So we're going to be using all kinds of different problems and the different operations throughout those problems. So the first thing we're going to do is we're going to read the problem, and we're going to decide what operation are we doing. Are we trying to add these numbers, subtract them, multiply them, or divide them? So number 1 says Max is putting his videotapes on a shelf. The shelf is 12 inches long. If each videotape is 1.5 inches wide, how many videotapes can he put side by side on the shelf? Because this problem has fractions in it, we know that addition and subtraction are not an option. So I know that I'm looking at multiplication or division. This problem is not asking for the area or the volume of something, and it does not include the word of. So it doesn't say 1.5 of something or 12 of something. It says I have 12 inches and I'm trying to put 1.5 inch videotapes in that space. So this is going to be division. It's going to be how many of something is inside another number. So how many of these 1.5 inch videotapes can we fit inside of the 12 inches? So I'm going to use division. And I'm trying to figure out if I take 12 and I try to put 1.5 inch cassette tapes in there, how many can I fit? So this is our whole number divided by a mixed number. So I'm going to write my whole number over 1 and I'm going to change my mixed number to an improper fraction. So 1 times 2 is 2, plus 1 is 3. And now I can do my keep change flip. So 12 over 1 times 2 over 3. 12 and 3 have a 3 in common, so this becomes a 4 and this becomes a 1. So 4 times 2 is 8 over 1. Now, when we solve word problems, these problems have a context to their answer, so we're trying to answer the question. So the question says, if each videotape is 1.5 inches wide, how many videotapes can he put side by side on the shelf? Well, he can put 8 videotapes. So your answers have to have context. They have to answer the question. Number 2 says Lila has 4.5 pies and she has 9 people to serve. How much will each person get if everyone gets the same amount? Again, we're looking at either multiplication or division because we're looking solely at fractions. It's not multiplying because it doesn't say that they get 4.5 of a pie or 9 of something. And it's not area and it's not volume. So I know that I'm looking at division. And this one I'm looking at a total amount divided equally. It says how much will each person get if everyone gets the same amount? That means division. So I'm going to take my 4.5 pies and I'm going to divide it amongst 9 people. So I'm going to change my mixed number into an improper fraction. So 4 times 2 is 8 plus 1 is 9. So 9 over 2 divided by 9 over 1. Because I'm going to write my whole number over 1. And now I'm going to do my keep change flip. So 9 over 2 times 1 over 9. 9 and 9 can cancel. And I'm left with 1 over 2. Well, now I have to use that 1/2 to answer the question. How much will each person get if everyone gets the same amount? Well, each person gets half a pie. Number 5. That's really weird. Should be number 3. Number 3. So I'm going to change that really quick. At a charity bike rally, 2/3 of the students, right there, that's important. 2/3 of the students at Lakeshore Middle School participated. If there are 1,200 students at LMS, how many participated? Well, 2/3 of the students means multiply. So I'm going to do 2/3 times 1,200. Well, I'm going to put that 1,200 over 1. And I'm going to look at, can I cross cancel? In this case, 3 and 1,200 do have something in common. So 1, and this is going to be 400. And 2 times 400 is 800 students. To answer the question, how many participated? 800 students. Number 4 says a lumber yard has a rectangular scrap sheet of plywood that is 3 3/4 inches by 1 1/5 inches. What is the area of the plywood? So that word gives away that it's multiplication. So I'm going to do 3 3/4 times 1 1/5. This is a mixed number times a mixed number, so I have to change them to improper fractions first. So 3 times 4 is 12, plus 3 is 15 over 4, times 1 times 5 is 5, plus 1 is 6 over 5. This is multiplication, so no keep change flip here. We're just going to cross cancel and multiply. So 4 and 6 have a 2 in common. 5 and 15 have a 5 in common. So the area of the plywood is going to be 9 over 2 inches squared, because area is in square units. For number 5, it says in 2.5 hours, Jolie can run 10.5 miles. How many miles per hour can she run? This is going to be our unit rate. So how many miles per hour means miles divided by hours. So I'm going to do 2 1/3 hours divided by, nope, that's backwards. So I'm going to do 10.5 miles divided by 2 1/3 hours, because it's miles divided by hours. So I'm going to change each one to an improper fraction. So 10 times 2 is 20, plus 1 is 21/2, divided by 2 times 3 is 6, plus 1 is 7/3. At this point, I can do my keep change flip. So 21/2 times 3/7. 7 and 21 have a 7 in common, so this is going to be a 3, and this is going to be a 1. 3 times 3 is 9, and 2 times 1 is 2. This is going to be 9/2 miles per hour. You could also change this to 4.5. I'm not requiring you to, but you can change it to 4.5 miles per hour if that is your choice. Number 6 says Isaiah has 12 cups of soup in a pot. If he pours 1/3 cup of soup into each bowl, how many bowls will be used? So I'm pouring the soup into each bowl. That each is going to be your division. So I'm going to do 12 cups of soup total divided into 1/3 servings. So 12/1 divided by 1/3. So when I do my keep change flip, I'm going to do 12/1 times 3/1. No cross canceling because both the numbers are on top. So this is going to be 36/1. That's going to be 36 bowls of soup. Number 7 says at Martin's, each candy bar costs 79 cents. If you want to buy 28 candy bars, how much money will you spend? So the example that I give with this one is I try to use something that doesn't have a decimal in it. So if I buy 28 candy bars for $2, it's going to cost me $56 because I'm multiplying $2 times the number of candy bars. The same thing applies here. I want to know how much money I'm going to spend, so I'm going to do 79 cents times the 28 candy bars to figure out the total cost. Remember to multiply decimals. We're going to count the number of decimal places. So this one has 2 decimal places. This one has none. So I have to add in 2 decimal places at the end. So I can just multiply the numbers without the decimals. 8 times 9 is 72. Carry the 7. 8 times 7 is 56. Plus 7. 56 plus 7 is going to be 63. Then I'm going to use a 0 to move over. 2 times 9 is 18. Carry the 1. 2 times 7 is 14. Plus 1 is 15. So now I have to add. 2 plus 0 is 2. 3 plus 8 is 11. Carry the 1. 5 plus 6 is 11. Plus 1 is 12. Carry the 1. And 1 plus 1 is 2. And I have to add the decimal back in. So I had 2 decimal places over here, so I'm going to move it 2 places in. So my total cost is going to be $22.12. The second question says, if you give the cashier $30, how much change will you get back? Well, if I want to know how much I'm going to get back, I have to subtract from how much I'm using. So it's going to be $30 minus $22.12. I have to include the 0 so that I can subtract. So I'm going to borrow from the 3 to make this a 10. I'm going to borrow from the 10 to make this a 9, make this a 10. I'm going to borrow from this, make it a 9 to make the last 0 a 10. 10 minus 2 is 8. 9 minus 1 is 8. 9 minus 2 is 7. And 2 minus 2 is 0. So I'm going to get $7.88 back. Number 8 says Axel hiked 21.48 miles in November and 30 miles in December. How many more, so that's one of our subtraction look-fors, miles did he hike in December? So I'm going to subtract 30 minus 21.48. Remember that to subtract decimals, I have to line up the decimals and include the correct number of spaces. So I'm going to borrow from the 30 again. So 3, 2, to make this a 10, 9, make this a 10, 9, make the last one a 10. 10 minus 8 is 2, 9 minus 4 is 5. Bring my decimal down, 9 minus 1 is 8, and 2 minus 2 is 0. So this is going to be 8.52 miles. Number 9 says Mr. Santiago has a 2,171 mile flight from Los Angeles to Toronto. If the plane travels at 520 miles per hour, how many hours long is the flight? So I'm going to divide how far he has to go by how fast he is going to figure out how long it's going to take to get there. So I'm going to put 520 into 2,171. Now, it's been a while since we've divided with big numbers. So the first thing I'm going to do is I'm going to create a little multiplication chart here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 520 plus 520 is 1,040. So this is going to be 1,560 plus 520, 2,080. 2,080 plus 520, 2,600. 26 plus 520, 2, 1, so 3,120. And then 0 for 3640. And then 4160. And then 4680. So it's been a while since we've done some long division. And I'm going to create my little multiplication chart. I just did it through addition. So for each number, I added another 520. So now I'm going to look at, okay, how many times does 520 go into, the first number that I can look at is the whole thing. Because it doesn't go into 2, it doesn't go into 21, it doesn't go into 217. So I have to look at the entire value. It goes into 520 4 times. So I have to put the 4 over the 1. Because it's in that very last place value. So according to my little multiplication chart, it should be 2,080. Now I'm going to subtract. 1 minus 0 is 1. I'm going to borrow. 17 minus 8 is 9. Now, we are not done dividing because we have something left over. So I'm going to add a decimal here. I'm going to extend my division bar here. and I'm going to add a 0. So here's my decimal, I add a 0, and I'm going to bring down that 0. So how many times does 520 go into 910? Well, it goes in 1 time. So 0, 11 minus 2 is 9, and 8 minus 5 is 3. 520 cannot go into 390, so I am going to bring down another 0. 3900 is going to be 7. So 3640. So 0, 6, and then 2. 520 does not go into 260, so I'm going to bring down another 0. This should be the last one, because 5 times 520 is 2600, so this is 5. And there's my happy 0. So how many hours long is the flight? It is 4.175 hours. So that one was probably the most difficult one that we've come across so far, only because we have to revisit long division, which we haven't done in a while. Number 10 is the last one. So it says, using the table, what is the total cost of the glass, resin, and stone? So I'm going to add all of these things, because what is the total cost means to add all of these things together. So 26.60 plus 23.00 plus 2.35. So 0 plus 0 plus 5. 6 plus 3 is 9. Bring my decimal down. 6 plus 3 is 9, plus 2 more is 11. Carry the 1. 2 plus 2 is 4, plus 1 is 5. So $51.95. And that's dollars, because that's the total cost of all 3 things. Okay, so I've kind of pointed out some different some different things that we can recognize in the word problems as you go to help you with the operations. Remember, if you're working with decimals, it can be any of them, so adding, subtracting, multiplying, or dividing. If it is fractions, it can only be multiplication or division. So watch out for that. We are going to focus on the fraction word problems first, and then we are going to work on the decimal word problems. So please come to me with any questions and use your notes as a resource.